Hello again from Max NG7M, and if you found this video, this is part 3, and I've had a busy day today. Stayed up last night late doing the calibration on my B26-RF2K Plus just to get my head wrapped around what you need to go through on the calibration process. This document is this video rather, is intended to just talk about what you'll need as far as your setup and all the additional equipment and tools. And some of you might find that I've gone over the top here, and I don't expect everybody to have all of this equipment that I'm going to show, but it just gives a good reference of what you'll need, and it'll make it a lot easier if you have some of the gear and the tools and everything ready for this. So a disclaimer. Again, I mentioned this in the previous videos, the source of authority here is not me. You need to spend some quality time on the Groups IO RF Kit forum, and always see that as the best reference of material. Just double check everything that I'm talking about and make sure you ask questions as needed and take your time. If you're going to spend this kind of money on a piece of equipment and enjoy it like you should, take your time, and there's no need to rush through this. I just can't see having gone through this in less than a day. I think it's well worth your time to take a few days to go through this. So especially there's a few changes to the documentation, and as of the time I made this video, you can see it in YouTube when this was posted. Image 55 of the OS and software for the amplifier has been updated, and so there's a couple documents that I'll touch on as we go through this pre-calibration setup. So we're finally getting to the fun part where you get to calibrate the amplifier and power it up and do a few things. So let's get started. I want to talk first about just the equipment I will be using here. Obviously, number one, you're going to need, let me get rid of the splash screen. Oh, the screen here, I added in DL7NB, Wolfgang, and NU6X Mark. I know who's done work in the documents. And so I'm sure I'm leaving out others that have been instrumental in making this project available to the amateur community. So very cool. It's a very cool amplifier. And I'm repeating myself, but I'd love to see this thing succeed and get a lot of support from the amateur community going forward. So let me move that out of the way. I'm going to, let me get rid of that. I've been making some reference images that we'll look at as we go through the next videos. This is, again, I won't do any of the calibration in this video. Look for a video 4 where I'll start the calibration process. And based upon recommendations from guys in the forum, I'm going to split that up into sections, maybe do the first 5 steps in video number 4, and then I'll decide how to split that up going forward. So let me turn on another camera here. I've got 3 webcams going here, and so I'm going to look at a few things. Obviously, you'll need this, number 1. So here is the, you can see my hand in 2 places there. Here is the amplifier. I have removed the front of the amplifier, and as you can see, it's down here. And I'll do a demo on this. We'll be remoting in via VNC to the operating system, and so we'll be able to see as though we were looking at the front panel. It just makes it so much easier to deal with the multi-turn pots that you'll see here on the B26 controller, which is this PCB right here. So number 1, you need the amplifier. You can see I hacked up my, I'm digressing a little bit, but I hacked up my little metal case modification, and in hindsight, I don't know if anybody wants to go to the extent of putting this case in. I also upgraded to the Raspberry Pi 3 B Plus and bought the fastest SD card I could find, which was a Samsung Evo Pro Plus or something like that. So you can tell it boots up faster. So I just wanted the fastest boot up time possible. Certainly you do not need to do that. It's not that much different than the micro SD card that ships with the amplifier, which seems to be a pretty fast card too. It is nice though having the better Wi-Fi, even though I probably curtail its abilities with the metal case. And the heat dissipation on the B Plus is a little nicer. They've included some heat sinks on the CPU and on the video chip, I think, if I'm not mistaken. So you need this. The next thing, I already talked about getting on the website and spending some quality time there, but print out the calibration manual. So this is the February 2018 manual for calibration for the 55 image, and I'm a little confused by that because image 55 just came out, but it's dated February, so maybe either the date wasn't updated or the image has been out there for a while. Guys have been either beta testing or working on it, but this was the last document. Download this, devour it, go through it a few times, and you'll be much better prepared to do the calibration. And anything I do wrong in the calibration, leave objective notes. And again, I certainly can't be responsible if something goes wrong with your amplifier. I'm just trying to do a nice service to the community that has jumped on board and are buying these amplifiers. It's a great project, and you'll learn a lot. There's not a lot you have to do on the kit, but once you get into the calibration, you're going to learn quite a bit. In the document that I just showed, which is in the file section on the website, make sure you go to the appendix and print this page out. The document, I think I misstated in the earlier video that it was 22 or 24 pages. It's actually 14 pages, and there's a couple pages. Really, the calibration procedure is like 12 pages. So print this out as a good reference, and it shows all the locations of the multi-turn pots that you'll be adjusting during the calibration process. So the next equipment I wanted to show, hopefully this won't get anybody sick, but the first thing you're going to need, right, and I'll get to the setup on the amplifier and the rear of the amplifier after I go through the equipment, which will include the, you need an accurate SWR and forward power meter, and then dummy loads potentially to, for all the testing. And so let me just show you that. Hopefully this won't make anybody queasy here, but number one, right, you're going to need a exciter. Okay, so you need a transceiver, and I'm using for this demonstration, and all along I have a K3S that I'm using. And now one thing before I jump to well, here I'll just show you a shot of the for my power meters, and I don't expect a lot of guys to have especially both these meters. I actually have a N8 LP Larry Phipps. That's telepostinc.com. I have his LP100 digital vector RF watt meter, and then I have one of the newer. It's the LP700, which is 7-inch touch screen, very similar to the screen that you'll see on the amplifier. And I'll be using these meters for the calibration process. It'll be interesting. You'll be able to see. I'm going to show you the software. So there's remote software for both of these watt meters, so it'll be part of the video during the calibration process. I won't have to actually have live video of the instruments themselves. But you'll see how difficult it is to get accurate instruments as far as RF watt measurement. There's so many factors that come into play. If I was going to get crazy, well, here, let me show you. If I was going to get crazy about this, which I don't know that I ever will, I would fire up something like what you see right here, okay, which is a Hewlett-Packard 4418A power meter. And with that, right, you use these power sensors, which can be very expensive unless you find them surplus, which is tough to do. But if I wanted to truly see the accuracy of my N8 LP meters, I would, right, you'd use, again, you'd get a precision. This is a 30 dB precision attenuator that can handle 30 watts, which would be perfect for some of the calibration here in the video, but this is like way over the top, right? And so you would put a 30 dB attenuator in line, which would drop the wattage of 30 watts. It would effectively divide it by 1,000. So then you'd get it down to a power level that you could pump into a RF power meter sensor. And here we're talking about incredibly sensitive measurements. And so you could do it, right? But hey, we're amateur radio here. We're not going to get into it that far. This is a lot of guys aren't this crazy about getting into some of this equipment. And then not only would you reference your power meter, but you'd get on a spectrum analyzer and use it as a reference. You'd come back and use your power meters, and so you could get pretty crazy doing some of that stuff. So so let me turn that off over here. And we talked about the exciter. Another piece of equipment, obviously, right? You're going to need a good digital voltmeter, and you need to be familiar to do this right. You need to understand how to do current measurements. So, hey, I mean, if you're an amateur radio operator, you should know this stuff, but you want to make sure when you do the current measurements later on in the calibration, especially, it'll be related to the bias, the idle bias current draw of the LDMOS devices. And so, you can't just throw this on to measure amperage, but you need to make sure it's in DC mode, because obviously we're measuring current in direct current, not AC. Most meters default to AC on current measurement. So the digital multimeter is critical here. And I'll have another camera on that for the measurements. You'll be able to see. So here, let me kick that on. Let's see how that looks here in this video. And so I've got another camera here, so I can. So here, right, we'll use this for like real-time measurements when the meter's on, and I'm just kind of seeing how that's going to work out here with the reflections. So DVM, right? A lot of this is obvious, but I thought I'd get very detailed here. And while I'm on I'm jumping around a little bit. Let's go back to the front of the amplifier here. Let me turn this other video off. We can make me a little smaller here, I think. Get me out of the way. Make this one bigger. There we go. I'll do a better job of adjusting the video here. In that second video, I was covering up the images we were looking at. So back to the front of the amplifier, you can tell I have a very detailed script here. So we talked about the DVM. I want to go through the tools that I found useful while doing this. And again, if I wasn't making these videos, I probably wouldn't be this detailed. I've got my layout of all my tools here. It's like a little operating table. And so a magnifying glass is going to come in pretty handy, woo, woo. And the bolts on the DC input to the RF palette are 7 millimeters. And if you're going to mess with the SMA connector, I think they're 8 millimeters. So that's nice. For the DVM, you are going to want, good quality clamp-on connectors so you don't short anything out. And these are Fluke brand connection. You can just slap these babies on your standard probes. It'll make your life a lot easier, especially when you get into the amperage, the bias. I've got, for the multi-turn pots, I've got a insulated little pot adjuster here, which is nice. It fits nice and tight in there and stays put, doesn't slide out. And that will be used a lot here as we go through the pot adjustments and initial turning all the pots down to their lowest values. to go through the proper calibration procedure. And then I noticed I have another little teeny tiny screwdriver here, which is metal, but I needed something very small for the multi-turn pots inside the SWR bridge, the standing wave ratio bridge, which obviously is covered in the calibration process. And then all the camera doesn't appear to be focusing that great, but you get the idea. You know, good screwdrivers, non-metal stuff to poke around, pencil for notes, some other screwdrivers I'm using. And this will be critical to make your life easy as you go through. I mean, rather than to try to, I'd hate to see somebody try to make an adjustment, check the voltage, make an adjustment, check the voltage. Yeah, you want to do all that hands off. So make sure you have some good clip-on little guys here, right, for your DVM. And again, there's been some changes to the documentation on the SWR bridge adjustments that will make it easier, but there still are some voltage checks where these will come in handy, so you can be hands-free to make the adjustment and then watch your digital voltmeter as you go. So that pretty much covers that equipment. I'm going to jump back to the watt meters and SWR meters, and so I'm going to let me show you quickly the software. So here, I'll turn this around. Whoops, just keyed the. So here's the two reference meters we're going to use, and I haven't powered on the LP100A for, man, it's been many years, but I pulled it out and threw it in line along with the LP700, and these are watt meters that sample the actual RF on the coax, right? You know, so you've got couplers that the RF will pass through, and then there's toroid couplers in there that sample the RF from the center conductor on the shielded coax. So what I'm going to do as we go through the process here, you can see my messy shack there. I will be running software that allows me to remote into those two devices. So I'm going to pull up all my ham radio links here and maybe make this a little smaller here, or actually turn it off. And so, hey, you can see my background here. Here is W4 Yankee November's custom faceplate for the amplifier. So shameless plug in there for Tim. I'm pretty sure it's Tim. W4 Yankee November, Whiskey 4 Yankee November. Send a note to him, and he can put one of these together for your new amplifier. And so, okay, I got distracted. A little shiny object there. So my LP700 has software that we'll be using here to where, right, if I'm, well, here, I'm going to turn that video back on so you can see that it's in real time, which is nice. So the software on screen is going to match the meter here. You know, I can key the amplifier here. So so it's in real time, and you know, if I key the amplifier, boom, you know, you're seeing the SWR and forward power time there. And I also have one, you know, to reference the, I better set that down so I don't drive you crazy there. And so then I also have software for the LP100, which is older. And when I was curious to see how well we'll be able to see that on screen. It doesn't look like it'll be that great. But just to reference the differences between meters, to me, the LP700 is going to be my reference, and then the LP100 is just a nice to have. It appears to be reading a couple watts lower kind of across the board. So when I'm keying, you can see the software on screen, and then you can see the real-time meter there. So if I go to tune, so the LP100 is showing 16.7 watts, and the LP700 is 18.8. And I just wanted to mention that because, let me unkey the radio there, or the exciter. This is pretty subjective as far as the accuracy of these watt meters. The LP700 is, as calibrated by Larry, is NIST traceable on its reference. The LP100 I've had for many years, and it appears like I need to send it back to be calibrated again. But I would, and I'm belaboring this point, but if you want accuracy, you need good quality equipment. If you're expecting, a cross needle meter on your 20-year-old MFJ tuner or whatever to be accurate, you're kidding yourself. So if you want accuracy, you need a good forward and reverse power meter, like a Bird 43, something as a good quality meter to use as a reference. So you're in the ballpark, right? You're going to be, let's say, plus or minus 5% or plus or minus 3% is actually really good. Some meters are just absolutely horrid, right? Especially across the range of power. So what I'll be using in this calibration demonstration, you can be pretty confident that I'm close. I'll feel better that I'm close in the ballpark. I'm not crazy accurate, like going down to the level of my power meter, my HP power meter, but that's going to take a lot more time if you really were that, I'll say, if you were that anal, right, it would take a lot of time to go through the calculations and make sure your attenuators are correct. So enough of that on the power meters. The next thing you're going to need is, and let me turn me off for this one. Over here. I'm going to turn me off because I'm going to drive you guys crazy again here. I'm going to shut off those virtual meters that were on the screen there. And let's see. Close that down. We'll make this big here. There we go. And so here we'll talk about the dummy loads really quick. And before I do that, I can show you the directional, or the couplers. So there's the coupler for the LP100. I actually have there's two couplers for the LP700. I have one for the low power side and the high power side, which I'll eventually get to if I continue to be motivated doing these videos. But the lower coupler there is in line with the LP100. So you've got to pass through. The power from the K3 is coming into the LPC501, which then goes out into the LP100, which then is connected to a pair, a dummy load. After it goes through the amplifier, I'll show you the back of the amplifier. So I'm skipping the amplifier here. We'll show the back of the connection to the amplifier. So for the calibration procedure, you need a good dummy load. You do not need, this is a Bird 1kW continuous dummy load, and well, you can key this baby down at legal limit for a long time. You put fans on it, it would be continuous. And it's sure nice to have these in the shack. You just don't have to worry about a greasy cantenna, which are fine. These are really nice. If you ever get a chance to pick up something surplus and clean it up, I highly recommend it. And then I also have a 600 watt one and then 150 watt. These are, the coolant is silicon based coolant inside these. So a good dummy load, right? Check the resistance on it. It should be very, very close to 50 ohms. These dummy loads are really nice because they're extremely flat at 50 ohms, 50 to 51 ohms typically, across a broad temperature range and across a broad range of frequencies. So the calibration procedure talks about you need a 25 ohm load, and so it talks about putting two 50 ohm loads in parallel with a T-connector, which I've done here. And so I set this up so it'll be easy just to switch. I can just grab the output, antenna output of the amplifier and switch it over and get 25 ohms here and switch it back to the 50 ohms. So, if you're going to be playing around in this hobby for a long time, I highly recommend you get some decent dummy loads. Look around, take your time on eBay, and you can find some amazing surplus equipment for pennies on the dollars. These babies new are just out of control expensive. I never would have paid it new, but used prices, and you clean them up, they're just like new. They'll last a lifetime and beyond in the shack. So, okay, enough of the shaky video there. Let's, looks like it focused there a little bit better. I think we're getting close on covering everything here. The front of the amplifier, we talked about taking the front off. Oh, this is good. I'm glad I remembered this. So to power on the amplifier, and you need to be careful here, I actually removed the toggle switch, which I'm not saying you need to do that, because you could probably lay the front of the amplifier with the touch screen down on a table or something. But for this video, it made life much easier. However, right when you've got 220 volts here, I believe the 220 volts is live here, so you need to be very careful with the toggle switch here. Otherwise, you're gonna feel the vengeance of 220 volts AC, which isn't fun. So be very careful. You know, just keep safety in mind there with that toggle switch. And let me rotate this around. We'll look at the back. If I can do this without, you know, getting too crazy here. So for the back of the amplifier, and this is all discussed in the calibration manual, right? I mean, some of this should be obvious. And this reminds me, I'm going to talk about making sure you have some form of cat control going to the back of the amplifier here. Here you can see the exciter input right here. So this is your transceiver in, which will be exciting the amplifier. And then the default antenna output is right here. So this is going to my dummy load, you know, whether it's the that I just described earlier, 50 ohms or 25 ohms during the calibration part of that. And just so I didn't get mixed up, I labeled the hot input right as red, because you're going to end up switching these around to calibrate the forward power on the SWR bridge and the reflected power on the SWR bridge. And you know, so you don't want to be mixing those up. And again, I'm just trying to be very careful and go through the details here. So down here, you can see that I have the key line coming in from my transceiver. So the key out on the back of the K3S, in my case, is coming in right here. You're going to need that even when you're for example, if I remember right, in some of the first, like the third step or fourth step, you adjust the voltage on the B26 controller to match the voltage that's on the power output. And so to do that, I believe you have to have the key in, so the B26 is actually looking at the voltage. That's just off the top of my head. Don't quote me on that, but you do need the key line, even if you're not you know, transmitting any RF, right? So you'll have to have that. Power in, obviously, the amplifier. Now, let me make a little commentary on this. I was going to do, I'm obviously an Elecraft fanboy, right? I've got a K3 and a K3S, amongst other things. But this USB here would be the cat control. So clearly you're using the serial port that's on, I'm assuming the serial port that's on the Raspberry Pi, or that's got to be the Raspberry Pi, I assume. And just the way that this was designed, right, it's got the female USB, and I can't remember whether it's the A or the B or whatever, but I didn't have a double you know, connector like this. Otherwise I would have used this to get the cat control going. I need to find an adapter or whatever, but that is a little unusual. Usually you have got that little square connection on the equipment side, and then you have this type of connector on your computer side, and those are the standard cables. So I just didn't, I dug around, I couldn't find the cable for the cat control there. So what I'm using is I'm using PA bridge, and we'll get into that next as I'm going to power up the amplifier, and we're going to look at VNC again as part of this particular video. So I'm hardwired into my switch here in the shack, and the amplifier is set up for DHCP, so it gets a dynamic IP address from my router where my DHCP server is, and we'll use that along with PA bridge to provide CAT data to the amplifier from my K3. So I'll show that, and then we're pretty close to being done with this video. It'll be short, right, compared to some of the other videos, that's for sure. Okay, so we're going to bring this back around here. Okay, and get that there. Okay, let's bring my video back. We're going to make this a little smaller here. Okay, let's get here. I'm going to leave me nice and small. So this really isn't part of, this would be particular to an Elecraft setup, but I'm going to run some software that gives me a virtual K3. So, you know, I'm right around 7 megahertz right now on my K3, and I'm going to fire up this software, and then I'll load PA bridge. And PA bridge is, let's see here, what's going on. Let me power off the K3, bear with me here. Get it to come on. There we go. Okay, I think I know what's wrong here. Maybe. Let's see. Oh, apologies, guys. Here, something's not firing up here to do the demo on my cat control. Well, but it's still tracking there. I should be good. Okay. I've been spending too much time on this. I won't be editing that out. So what I'm getting to here is the point where I'm going to turn on the amplifier. Okay. So I'm going to come over here carefully to the toggle switch. You can see over here. We're going to fire up the amplifier. Okay. And since I don't have the front panel on, obviously there's no screen. And so I need to wait for it to boot. And you'll hear when it's booted up, you'll hear the relays click. And then you'll also see the power supply, the switching power supply fan come on. So you'll know you're booted up there. And then we can use VNC, the VNC client, to remote in as though we were looking at the front of the amplifier. So there, that shows you how long it takes for the software to load up. And so you can see the fan fire up there. It's just in a low RPM mode there. It's virtually quiet. And so now back to my desktop. I'm going to come over here and I'm going to fire up VNC. And I've got this set up to automatically connect. And there you have the amplifier software. Or, you know, it's the virtual screen. It's as though you're sitting in front of it here. Now you'll notice when I pulled the software up, right up here, if you can see my cursor there in the video, the cat control, I'm spending a lot of time here on the cat control, but it's important when you get ready to do the calibration, because you'll be testing the low-pass filters, you know, that are underneath the antenna tuner if you have that. So it's important to have the cat control so you can double check that all those filters are switching correctly with the relays. So I'm going to provide cat control using what is called PA bridge. So right now it can't find any cat data, so it has defaulted to the universal interface, which is a frequency counter. So if I were to key the amplifier and just send some low RF to the amplifier, it would know what frequency I'm transmitting on, as long as you have completed one of the calibration steps. So the frequency counter in the amplifier, right, knows that it's on the right frequency. So let's go into the setup here. So I'm going to click menu, and we're going to go to rig control, and I'm going to switch to PA bridge, and I will run the PA bridge software now. But now this is getting into too many details. The PA bridge software works in conjunction with DXLab Commander, and so I am starting up. I've got my DXLab launcher here. I'm going to fire up Commander, which just started up there. You can see that it is. So here's DXLab Commander. It's tracking my transceiver as I tune the transceiver. You can see that tracking. So now I'm going to fire up PA bridge, which is going to send a UDP broadcast via TCP/IP over my network, and the amplifier will be able to hear those broadcasts. It's an unacknowledged broadcast of data. That's what the UDP protocol is. And so the amplifier, if it gets the right data from the PA bridge software, which is getting frequency data from Commander's getting frequency data from the cat feed coming from my K3S. So there's, it's kind of a chain of data going on there. So now I'm going to fire up PA bridge, and we'll pull it down onto the screen here. Okay. So now the PA bridge right here, it's connected because I selected it up here. Right? I selected PA bridge, and here's the PA bridge software. And incidentally, Delta Lima 7 November Bravo, Wolfgang is the developer of this software, and he also wrote the UI interface and did all the magic with the software interface that we're using over here. So very cool. Kudos to him. So now when I hit close here, we should see a green connection here. I wonder if I'll need to disconnect, reconnect. Okay, let me go there again. Cat, PA bridge, close, connect. There we go. So now this is critical, right? You will need some form of cat control. The calibration manual, and I'm jumping ahead a little bit, but if you're prepared, you'll just be able to walk through the calibration without doing a lot of work in between the steps. And so I thought I would describe some of that here to try to make those videos a little shorter. So there's different ways you can get the CAD information to the amplifier. You can use the universal mode, which is the frequency counter, or you can use the ICOM protocol. You can use Jesu's protocol, or you can use actual CAT protocol where you select the rig, which I'll end up doing. I won't be using PA bridge long term. I'll just get the right USB connector for the back of the amplifier. So here, once all the planets are lined up right here, right, this software can kind of be removed out of the picture along with all the DXLab stuff. And now as I tune the transceiver, you'll see up here the tuning segments. Looks like it's about every 8 megahertz here. As I'm tuning my aircraft radio, right, the amplifier is following the frequency. And then if I change bands, I don't know if you'll be able to hear that, but that second click was the amplifier low-pass filter relays kicking in to show 14, so it's using the low-pass filter for 14 megahertz. If I go back to, let's say 80 meters, you'll hear the K3, and then just slightly after that you heard the amplifier clicking. So you want all of this enabled for the calibration procedure, unless you want to just use the frequency counter, where you have to key your exciter, right, and then the amplifier will pick it up. I prefer to use CAT because the amplifier is already on the frequency. There's no RF. You're not always bumping your key to see what's going on there. I think that pretty much kind of covers it here. I don't think I missed anything before I take a break here. I may not make it to the first calibration procedure video tonight, but we'll see how far I get. If you don't see that posted tonight, the next video number 4, you'll know I'm out of town. It's not going to happen till the end of the week, next week. So thanks for the thumbs up, everybody. Click the thumbs up if you like the video in YouTube, and it's good to see the interest in these videos. And again, I'm repeating myself, make sure you double check anything and everything I say. Make sure it matches the manual. If you have one of these amplifiers and you're preparing to go through the calibration, just double check, ask questions on the forum. Guys are very responsive. Chris and Reinhardt are very responsive. And enjoy. Look for the next video here. We'll see if I can get this out there before midnight tonight. All right, 73.